Hello, I'm Lewis Tyler, Managing Editor of International Fire and Safety Journal. Welcome to today's podcast. I'm delighted to have with us Ms Zhao Li, General Manager and Chief Technology Officer of ProSense Technologies. ProSense is a global leader in the gas sensing industry, dedicated to empowering safety through cutting-edge sensing technology. ProSense focuses on developing high-performance sensors and sensing solutions for critical safety applications, including energy storage systems, industrial safety, and residential life safety. Ms Zhao plays a key leadership role in both technology development and global strategy at ProSense. Before we move further into the discussion, I would just like to take a moment to congratulate yourself, Ms Zhao Li, from ProSense, because you're an active technical committee member for several important safety standards, and we understand that you've recently been recognised by UL Standards and Engagement as an outstanding female technical committee member, which is, of course, I think we'll all agree, a fantastic recognition of your technical contributions and leadership in safety standards development. So starting off with a congratulations on the well-deserved honour, Ms Zhao, and it's of course a pleasure to have you with us. Now, we also spoke earlier at the fire safety event, I think it was around a month ago now. We touched on a plethora of kind of topics, but I just wanted to start off really. So we spoke about NFPA, but I want to bring the conversation to start off this podcast to NFPA 855-2026, which highlights some potential concerns regarding catalytic combustible sensors in BESS environments. So from your perspective, what are the key environmental factors in BESS battery energy storage systems that can influence gas sensor performance?
Yeah, hello, Louis. That's a very good question because nowadays the lithium battery used with the BESS or the data center, this application is very hot. And most of the batteries, the systems come from China. And in fact, there are some after-sales service problems. That means there are some failure with the combustible gas detectors on site. Because this is a very new application, and the old gas sensors, maybe they cannot be suitable for application in this field. For this application, there are three very big challenge for the sensors applied in this field. The first one is that for the lithium battery system tank, there are a lot of silicon glue is used, which will cause a lot of very high silicon concentration inside, especially when the system is not be put into service. And the second one is that there will be very high and low temperatures. Nowadays, what is recorded on site is the temperature range can be minus 40 to more than 80 centigrade. And the third one is there are a lot of VOC gases from the paint, the plastic materials used inside. All of these three will affect the sensor's performance, especially for the catalytic combustible sensor, which is very easily be poisoned by the silicon gas. So when the sensor are using on site, these three are the very big challenge for this application. So if we want to choose a sensor that have a good performance in this field, we must take into these three factors into consideration. That's the explanation to this question. Thank you, Louis.
There's a fair bit of insight there, but I just wanted to go back to something we discussed before, really, which was the transition towards solid-state battery safety monitoring. So how are you as a company, ProSense, preparing for this transition?
Solid-state lithium is the next generation of lithium battery because of the usage of the liquid electrolyte in the conventional lithium battery. Small runaway cannot be totally avoided. So in order to solve the thermal runaway problem. Now, the R&D of solid-state lithium battery is very hot all over the world. For this application, the safety problem is quite different from what is for the traditional lithium battery. For traditional lithium battery, we need to prevent thermal runaway, but for the next generation solid-state lithium battery, especially the sulfide electrolyte-based one, the biggest challenge is the hydrogen sulfide generated when the package of the battery is not very good, when there are some damage with the package, hydrogen sulfide will be generated. This gas is very toxic, even at very low concentration. So we must try to detect hydrogen sulfide at very low concentration. But the present hydrogen sulfide sensor cannot be used in this field because the solid-state lithium battery will first be put into service with the vehicles. For the application in vehicles, the temperature range must be at least minus 40 to 105 centigrade, and the lifetime must be more than 10 years. And the most important is that we cannot take the sensor back to the laboratory for recalibration. So there is new requirement for the sensor, the hydrogen sulfide sensor applied in this field. So ProSense are always focused on development of sensors that can solve the real problems met in especially new directions. So we developed a high performance hydrogen sulfide sensor which can be used from minus 40 to 125 centigrade temperature range and has more than 15 years lifetime. Now this sensor has passed the test of the top 3 lithium battery manufacturers in China and will be tested, will be launched together with vehicles very soon. So that's our solution for this application.
Now, I think we also discussed portable generators, and I think it's fair to say that, unfortunately, they have been involved in many carbon monoxide incidents. Obviously, the application also presents unique sensing challenges. So what are the main technical difficulties for CO detection in those portable generator environments?
Portable generator is widely used in North America. For this application, to prevent the CO, the carbon monoxide poisoning, we integrated a sensor on this equipment. The challenge for the CO sensor integrated in this application is the poisoning of the E10 gasoline. The E10 gasoline is widely used in North America for this portable generator. E10 gasoline means there are 10% of alcohol and 90% of gasoline. Both of high concentration of alcohol and gasoline, these two vapor are vital to the poisoning of CO sensor. So these are the biggest challenge for the application of CO sensor in this field.
Now, just to touch back on that again in terms of those issues, how does ProSense go about addressing those issues in CO sensing solutions for portable generators?
For ProSense, because we made our own catalyst. The catalyst is the heart for the electrochemical sensor. If you want to have a good performance for a electrochemical sensor, the catalyst must have good performance. Just like us, if we want to have a healthy body, we must have a healthy heart. So thanks to our talented catalyst team, we modified the catalyst according to the requirement in this field. We make our catalyst has good anti-gasoline poisoning ability. So when we are used in this field, the sensor has a very good performance. For ProSense, all of our sensors, we just get high performance according to the requirement about the vertical application. We modified our catalyst, and together with the other technique, we make our sensor works excellent in this field.
And then just to move on from that, I know sensor reliability for residential CO alarms is, a huge issue. So how does ProSense ensure sensor reliability for residential CO alarms?
The residential CO alarm application is quite different from the portable generator. We mentioned the CO sensor application in the BESS, in portable generator, and also in this residential CO alarm. Although all of them we detect carbon monoxide, but the requirements are quite different. For the residential CO application, it requires that the sensor must have long life, because nowadays the alarm, they require the sensor to have more than 10 years lifetime. And the second one is that they hope the sensor can have high reliability, high accuracy at very low concentration, because the alarm point is at 70 ppm in this field. So there will not be high concentration of carbon monoxide, but the accuracy at a low concentration is very important. The third one is that the interference gas in this field is mainly about the daily life, like low concentration alcohol and interference gas from the fuel and the other things. So ProSense, we also modified our catalyst together with the other technique. So we ensure our sensor is suitable for this application. It has a very good performance. Now we have a very high market share in this field.
And then just, I know we've had several kind of long discussions about the industry, and I'm conscious of taking up too much of your time, but I'm interested in, looking ahead. What role do you, and both yourself and ProSense, what role do you see advanced gas sensing technologies playing in the future of safety critical industries?
I'm very happy, or I'm very honored that I'm in the field of a gas sensor, because I think sensors, not only gas sensor, they play a vital role in the safety environment. Because if we want to prevent hazards, we must know there will be hazard. So only sensors can tell us there will be something happen. We must be prepared for this. So I think that high quality sensors play a very vital role in the safety critical industry. I hope that all the sensor manufacturers, we can work together to make more talented or make better sensors that can solve the real problems in the real application, not just with good performance in laboratory. So advanced sensing technology will play the critical role in this field. And we hope that we can work together for a better and a safer future.
Well, thank you, Ms. Zhao, for sharing your valuable insights with us. I think it's fair to say we're all going to take plenty away from the discussion we've had today and previous discussions that we've had. It's been, I think it's fair to say, fascinating covering the evolving role of advanced gas sensing technologies in critical safety applications, from battery energy storage systems and solid state batteries to portable generators and residential CO protection. I think your perspectives on how sensing technologies and safety standards on how that must evolve alongside emerging energy technologies have been really informative for listeners. So once again, congratulations on being recognised by UL Standards and Engagement as an outstanding female technical committee member, a very well-deserved achievement there. And thank you to our listeners for joining us today. So stay tuned for more conversations on innovation, safety, and the technology shaping the future of fire and life safety. Thank you.